We are set. We are set to do some experiments. I've got my 2 flasks. I got my universal indicator in each flask. That's going to show us the pH value that is found in each flask. Right over here, man. And we are going to start adding acid or base to each flask and see what happens. We're also going to maybe do some different experiments today, too. So let's go here, baby. What do we got? Let's start adding some sodium hydroxide to, let's say, the flask on the left, shall we? Here we go. A couple drops. Hello, detonator. It's been a while. It's good to see you on board. Oh, we got some nice action, color action going on there. What's happening, detonator? What's going on in life? I'm doing fine. Just enjoying a few experiments here on a Saturday afternoon. Hope you're doing well, too. Welcome aboard, everybody. We are doing some experiments here with some universal indicator, some acid, which I'm adding right now over here on the right. Hydrochloric acid. And boy, look at all those colors developing as the acid and the base react and neutralize each other. Looks like we're ending up with a pH of about 6 over there on the right. Yeah, sure enough. Let's keep going. Nice. Detonator is getting ready for med school. Love to hear that. I'm continuing to add acid over here on the right. Imagine the MCAT is maybe what you're studying for. Detonator. Perhaps. All right, let's add some sodium hydroxide base now to the flask on the right. 1, 2, 3. Let's see what kind of color action we can get. I'm seeing there. Oh, we didn't quite catch it right. We're going to try that again. I think I can get that better. Here we go. Hello there, Akash. We're going to make this acidic. I'm going to add 1, 2, 3. How many drops? Oh, that's pretty. It's like a traffic light. Let's go to 4 drops. Yeah, it's neutralizing it, board pyro. So what I've got in there is I have universal indicator added to both of these flasks. Universal indicator changes color depending upon pH. These are different colors you're going to see. So over here it's like a pH of 4, maybe pH 5, somewhere in here. Over in this flask it's like pH 3 or below. And thanks, Erikosh. And then we're gonna add some sodium hydroxide base. That'll cause the pH to go up, and it'll cause the color shifts to go more blue. Crab, I'm sorry to hear that. Here we go. Let's start adding a bunch of base here. Let's see. Let's go like 1, 2, 3, 4 drops of base. Detonator. The indicator I'm using is universal indicator. It is a mixture of 4 different indicators. Hello there, Nabara. Hello there, Goop. We don't want to be sipping any of this because one of the indicators, one of the dyes that's present, I mean, I guess you can if you want, but one of the dyes that is present in these flasks is phenolphthalein, which is a laxative. So, I don't think that'd be a whole lot of fun, but, to each their own. I'm adding acid to each flask right now. Hey, we got over 100 people. I think once we hit 200, I'll do this other experiment I have ready for you. Oh, do I have the food coloring ready? Do I have the food coloring ready? Oh, no. Where is it? Yep, I do have it. Okay, so I am prepared to do another experiment. Let's make sure I got that. All right, let's see. No, we don't want to drink any of this stuff. What are we going to do? We're going to add 2 drops, 3 drops of base over here on the right. I want to capture the rainbow. Sometimes that's... So hens ask, what is the... There it was! We got a little... Hello there, Peace. We got a little rainbow action there. So the pH of these depends... well, I should say is displayed by the color. And you can see these different colors here. Yeah? Hey, thanks there, Flavorium. Bee jogging, I'm not drinking. So, the the pH is somewhere between 5 and 6. And as the color changes, you know, from the addition of acid or base. Here, I'll add acid to this side over here on the right. We're going to add some acid over here on the right. That's 5 drops. We are going to add now some base over here on the left. Sodium hydroxide is the base that I'm adding. What, I had like 2 drops there? Wow, detonator, that is a long time. So yeah, you can see as I add the base, the color shifts to a more violet or blue. When I add the acid, it goes to red. It is pretty cool, board pyro. Thank you there, Hans. Now what I'm going to do is I'm going to add some acid to this flask over here. Here we go. Let's go like 4 drops. 1, 2, 3, 4. You can see the red color grow in the middle. And then once that material hits the bottom, it gets pushed out along the sides. And we see a whole bunch of beautiful color changes. And then over here on the right, I'm going to add base. No, Leon, this acid will not melt through anything. Hold on, 1, 2, 3. You can see I store it in this flask here. It doesn't go through the plastic. Pulse, I have no idea. I'm not a synthetic chemist. I can't answer that question. Looks like my sodium hydroxide's out. Where's my other? Here we go. Okay, we got Eagles fan in the chat. I happen to be rooting for the Lions. It looks like those two are going to meet next week, I'm thinking. Yeah, I know some math. Not going to happen, King. How strong are these acids? Yeah, I am, Hans. I'm a chemist. So the acid is 20% by weight hydrochloric acid. It's about, 1,000 times more concentrated than the hydrochloric acid in your stomach. Come on, Maddox. Maddox and Mila, I'm with you. We got a little Honolulu blue going on over there. Look at that. Look at that. And yeah, we're going to go ahead, and there's some Eagles fans in the chat. We're going to go ahead and try to make it a little bit of Eagles green over here, okay? A little bit of Eagles green. Oh, we got it up at the top. What do you think? I think we got it. We got Honolulu blue on the left, and we got Eagles green on the right, huh? Deck the Sun, you're not going to want to drink this because one of the dyes in this mixture of dyes is a laxative. It used to be the main ingredient in X-Lax. Hello there, universe. Okay, let's add some acid to both of these. I'm going to add some hydrochloric acid, 1, 2, 3, 4 drops over here. Hydrochloric acid is the same acid that's found in your stomach. I'm going to try to get it pure red for you. Radin. So, well, there you have it. There's your pure red. So you can see as I add a bunch of hydrochloric acid is the same acid that's found in your stomach. It's just that the type I'm using here is like 100 times to 1,000 times more concentrated than what you find in your stomach. How do we test for acidity in tap water using at-home ingredients? Well, Zaf, what you can do is you can go to the grocery store and you can buy some red or purple cabbage. Sometimes people call it purple cabbage. Sometimes they call it red cabbage. And then you're going to boil that stuff. And when you boil it, you're going to find probably a violet color, although other colors will result. You see, red cabbage contains some compounds known as anthocyanins. There's a class of compounds. And anthocyanins change color in acid or base, just like the mixture of chemicals I'm using here changes color in acid or base. The difference is the anthocyanins are going to show these color changes. So the anthocyanins, like if you put it in some vinegar, it's going to go red. If it's more like slightly acidic tap water, it'll be violet. If you add some baking soda, it'll probably turn blue. You add some ammonia, it'll probably turn green. Can I make gold? I'm not sure I understand the question. There's a little bit of Eagles green for the folks out there. Thank you there, Mary Blushes. Okay, let's add some hydrochloric acid to this flask over here on the left. All right. And over here on the I'm adding acid. Let's add base over here. Radin, black is not possible with this mixture of chemicals. Hello there, Lisa. Glad to have you on board. Thank you there, Adrianka. Do it with a leaf of red cabbage. Mary Blushes. I don't have red cabbage, but let me tell you what I do have, and we can try using this. Hold on. What I do have, and I'm not sure this is going to work. Oh, let's see. Let's get this. Let's see if I can get another stir bar going here. What I do have is some cranberry juice, and cranberry juice does indeed contain anthocyanins. So we can give this a shot. Cranberry juice doesn't always work as well as I'd like it to, but we're going to try it. We're going to try it just for the heck of it, okay? So we're going to see if we can get this cranberry juice to act like an acid-base indicator. So we're going to take this flask off right here. Forgive me while I'm getting all this stuff ready. It's tough for me to read the comments when I'm getting experiments ready. And I'm going to go ahead and pop the magnetic stir bar in there. You can see it bouncing around. And let me get it spinning. Oh, I got it spinning too fast. Let's try again. Here we go. Button Squad wants to be a storm chaser. Thanks, Nobara. Yeah, that little guy's spinning pretty good. So we're going to put in the cranberry juice now, which contains acid-base indicators in them, a class of compounds known as anthocyanins. So in they go. How do chemical properties and reactions influence the way colors mix, and why do some combinations produce unexpected results? I apologize. That question is just a little bit too general for me to be able to answer. I'm going to top this off with a bit of distilled water. So let's put a little distilled water in here. All right. And now let's see what happens. Hello, Gigabean. Welcome aboard. We're going to see what happens if we start messing around with the cranberry juice. So, Mary Blushes says they always add apple cider vinegar to their purple cabbage. Oh, yeah, absolutely. Going to give you a nice red color. Dissolve copper in a mix of ammonia and hydrogen peroxide. That sounds fun. Here we go. I'm sorry. Aniket, I think you might be thinking I'm wasting this, but I love doing experiments. So, to me, if I do an experiment with something, it's not wasted. Here we go. I'm going to now start dropping. You can see up here at the top, I'm going to start adding drops of base to this. In goes one drop. I can't drink it now. I mean, now you're not going to want to mess with this once I start adding all this other stuff. I'm not seeing much of a color change, but there's quite a bit of citric acid in the cranberry juice. So it's going to take a little while to neutralize all that citric acid that's in the cranberry juice. Let's see what kind of color shift we get. I should have had a control color out. Won't there build up a lot of salt in solution is the question. It won't, because the salt that's formed dissolves in the water. So you're not going to have salt build up. I mean, yes, the salt builds up, but it's not like you can see it or anything because it dissolves. Look at that. We got some color shift there. A little bit of black color. Huh? As the base starts to work its way through the cranberry juice. Hey, thanks, Eric Hans. Can I teach you organic chemistry? It's been a long time since I had organic chemistry. I'm not the one you want to learn that from. You're right, Radin. We got you some black. Yep. But you can see, and I mean, really, it's more like a darker color on addition of the base. All right, let's keep adding. I'm going to keep adding base. It kind of went from like a sharp, crisp red to more I'm going to call this like a brownish red. I'm adding more base right now. I'm going to give it a big old squirt. And you can see that color change is really starting to shift. It may be easier to see what's going on if I cut the light off. There's an effect going on, I think, with the light that's making the colors difficult to see. So I'm going to cut this off. So yeah, now you can see it's like a dark orange-brown color. Now I'm going to start adding acid, and we'll see if we can get it going in the opposite direction, okay? Hey, thanks, Sarah. Madge Espers. Pleasant. What am I trying to achieve? Just messing around with some science experiments, that's all. Luna, what we are doing is I'm adding acid to cranberry juice that has been made alkaline. So I'm trying to neutralize the cranberry juice and see if we can't get that sort of brown color to head back to red. And I think I'm successful. I think that's starting to look like it's starting to clear up, isn't it? It's starting to get more red in color as I've added the acid. Would a wooden draw project protect you against lead 214? I imagine that's an alpha emitter. Gigabean, I'm not gonna comment too much on how to protect yourself from various radioactive isotopes. Oh, cool, Nabara. It is like a maroon, yeah? Sorry there, Jim Bros. Sorry I missed him. Pop it back. Pop back the comment again. I may be able to see it. Nobara is asking, can I please teach you how it changes color? It's a little complicated, but we can talk about that. So, what's up, unknown error? What happens if I turn into Jello? Hey, that's kind of cool, though. We got this back to like a nice crisp red color. So it looks like the cranberry juice experiment worked. It was a success. I'm going to pop this off of here because the color changes are not nearly as interesting as those that go on here. So I can talk a little bit about the theory of how these flasks change color on addition of acid or base. It's going to be more complicated than this. I'm not going to give you a comprehensive answer, but what I'm going to do is I'm going to give you a feel for how these color changes occur, and I'm going to do that by describing just one of the molecules that's present in these flasks. Here we go. Let's add some acid here. Let's at least get something going on so we can see something while I'm jabbering on about the color changes. Hello there, Arva. I'm going to add a couple drops here of acid. Let's add a couple drops of acid over here. So the one molecule I'm going to talk about that's present in universal indicator, there's a whole bunch of them. So, these are the colors of universal indicator, and they are displayed because we have 4 different dyes present in the universal indicator. Those dyes are thymol blue, methyl red, bromothymol blue, and phenolphthalein. And the one I'm going to talk about is phenolphthalein. Now, phenolphthalein is a ring-shaped molecule when it's in an acid. So here, let me get some color changes here while I'm jabbering here a bit. Let's just put a couple drops here. And I think we're going to just add a bunch of base here and kind of watch the slow color change over there on the right while I'm jabbering on. So phenolphthalein, in the presence of an acid, it's going to be ring-shaped. And I'm going to put this little circle here. And that circle is supposed to represent the fact that in an acid, there's a lot of protons. So this little bottle cap is representing a proton. And when there's a lot of protons around, the phenolphthalein molecule latches onto those protons, and that's what sort of gives it its ring-shaped structure. You can think of it that way. And when the phenolphthalein molecule is shaped in a ring like this, it's colorless. Well, in a base, when there's a lot of base around, bases accept these protons, so they pull the protons off. So when there's a lot of base around, or you're in an alkaline solution, these protons are lost by the phenolphthalein, and when the phenolphthalein loses a proton, it goes like this. It goes, boop, it pops open. So it goes from a ring-shaped, colorless molecule to a molecule that has an open structure, and this open structure happens to be colored. So that's why when there's a lot of protons around, you get a lot of phenolphthalein molecules that are bound to protons and everything's colorless. But when there's a lot of base around, that change in structure causes a change in color. And it looks like we've got some interesting stuff going on over here in this. We got a pH gradient happening. Last call for fruit punch. Hey, Big D, we're gonna block you here in a bit. We're gonna block you here in a bit. Just letting you know, we don't need that kind of crap in the comments. Yeah, we got a nice little pH gradient here. It is. It's kind of interesting when you turn the stir bar off. Don't sweat it. Don't sweat it, man. No big deal. So yeah, when you turn the stir bar off, you get like a pH gradient. Isn't that cool? It's beautiful. All right, universe doesn't want me to mix it, so I'm not. But while that's not mixing, I'm going to play around over here. You'll notice that this usually has a pH gradient that goes from like high pH down to low pH from bottom to top. It does look like a mocktail, doesn't it? Looks kind of delicious, but of course we wouldn't want to drink that. Another thing that we often see, sorry, the comments are coming through pretty quick. I apologize, I can't quite keep up with them all. But another thing that we can often see, like this, see this thin red line that is in the solution. That happens because, I'm adding acid, so of course acid is going to turn this red. But another effect that's going on, which is why this remains red and the outside is not changing color quite the same, is because of the vortex effect here. You see, just like a hurricane, the eye of a hurricane has low pressure in the eye. This vortex has low pressure in the eye, and material moves from high pressure to low pressure. So that material that's in the center, here I'll add some base so you can see it happen again. Let's add some base. The material that's in the center, it's going to tend to remain there because it's in a low pressure region. And material tends to move from high pressure to low pressure. So if something's already in that low pressure region, it's going to stay there. Thank you there, The Glitch. I appreciate that. We got a sub. I appreciate that. Hello, base dude. Welcome aboard. I'm doing well, Adiaman. Oh, that's cool. Navarre is liking some hurricanes. Good to hear. Canada and America on the right. Can I slowly stir the textured one with a stir bar? Sure, we can try to get that going. We're gonna try to just barely get it going over here. Thank you there, Madge. That's a real slow stir. Hello, someone from Russia's on board. I appreciate that. I apologize. I don't know how to pronounce your name. Hello, Boyd. Thank you, Mr. Chippy. I appreciate the sub. Wernich wants to know what is our favorite color. So put the heart emoji in the chat that displays your favorite color, and I'll try to make them for you. My favorite color, I kind of like violet. I really like violet color. Yeah, the base dude. I do know electrochemistry fairly well. I've published some papers on electrochem. So I mean, I'm not an expert in electrochem, but I have published. I have published papers on it, so I know quite a bit about it. Look at all those colors coming through. We got some red, we got some green, we got some blue, we got some violet. Very cool. Some like pink. Sorry, I can't make pink for you. I've seen a lot of blue, and blue's tough to get, so we're going to try to make some blue. To do that, notice over here on this side that we're at violet. I got to drop the pH to get to blue, so I'm going to start to add some acid over here. Am I Walter White? I am not. Okay, here we go. Let's add some acid over here. I'm going to add just a single drop. Let's see what happens. Someone wants a little orange. Universe liking the copper salts. Alameen, thank you for the sub. I appreciate that. How do you become this smart? I don't necessarily think it's smart. I just have a lot of experience studying chemistry. It's like people. Man, there's people who are smart at all sorts of different things. It's just people who spend a lot of time in a particular area. You just get good at it. I see some people want some. Oh, hello, Joyce. Welcome aboard. Joyce. I can't get this blue color. I'm going to try over here. Come on, just give me just a little kiss of acid right there. Let's see if this does it. Oh, we got a flash of blue, but it went to green. Dadgummit. Well, I'm going to add a drop over here on this side of base, and we're just going to try to just give a little bit of base over here on the right. I'm having such a hard time making it blue, but we're going to try. Let's see. Thank you there, The Glitch. Colin, welcome aboard. We got some blue, baby. Come on now. Oh, I think it's like a violet blue. Unknown wants some green. All right, Unknown, we're going to get you some green. We're getting some green. And then we're going to try to get the yellow and the orange. Right now, we're going for green. Here we go. I see a lot of orange, boy. I'm seeing a lot of orange. Is it a coincidence that the universal indicator is VibGyor? I don't know. I don't get the reference. So I'm trying to make blue. Adiaman, you can consider this a titration. Sure, you could consider this one. Can I make it glow in the dark? I cannot with the chemicals that I have at hand. I can't do that. Can't do it. Double rainbow, Jim Bros. Come on, man. I'm trying to make green for folks. It looks like I got a little bit of like an aqua blue over here. Got a little bit of green. Come on, I got you your green. And we're going to try to make this blue over here. I'm going to just try to add another sniff of base to get that pH just right. I think I went too far. I think I went too far. I don't think that's going to stay blue. Dadgummit. There we go. How long would it take to drink an above ground pool? Oh, man. Oh, the questions. All right, I think I'm going to get it over here. What if I add sodium to that? I'll tell you what, the base dude. You go ahead and look through some of my YouTube shorts, and in some of my YouTube shorts, I do experiments where I put some sodium in water. You can check that out. Yeah, check out my YouTube shorts if you like this kind of, just looking at science where you have some fun. It looks a little bit beautiful, and you can learn a little something along the way. That's what my channel is about, is looking at the beauty in the world around us through the eyes of science and trying to just introduce you to scientific ideas and to, just maybe learn a little bit, maybe pick something up here or there. That's what my channel's about. Okay, I'm so sorry, Tim Bully and Plain 10. I am so sorry. We're going to try to get you some orange. We're going to keep going. Orange is another tough color to get. Joyce, I apologize. I cannot make it pink. So, Unknown asks, what's the difference between organic and inorganic substances? It's pretty simple. Generally speaking, organic substances contain the element carbon, whereas inorganic substances do not. Now, there's a few exceptions to that rule, but nevertheless, that's basically the idea. There's your orange, folks. And Elijah wants it red for the Chiefs. I saw that, so we're going to go let me leave this orange just for a bit. I'm thinking we almost got some Honolulu blue over here, but I think it's just a little bit too green. The base. I am not an organic chemist. I'm a what's called a physical chemist. So it's kind of like you do physics and chemistry at the same time. Okay, Hans is saying it's blue. So if Hans thinks it's blue enough for me. It kind of looks like the dolphin colors, doesn't it? The Miami Dolphins. Do you think that if you eat 1,000 nails, you'd become magnetic? Yeah, probably. I'm sorry you feel that way, Hack. Okay, here we go. Let's make it red. Here we go. You heard violet was only made because Newton really liked the color? I don't... Okay, I apologize that my answer is going to sound stupid, but it seems to me that the color violet existed before Newton cared about it or not. What's the most obscure chemical thing I know? Asks Universe. Whoo! What is the most obscure chemical thing I know? Well, I don't know if this is obscure. I just found it interesting. I made a video on this. So you may have heard that people say, there's your green, by the way, that people say that, the water that we have today is the same as the water that was around the time of the dinosaurs. And that means that, in a sense, because the water's just part of a cycle, all the water that we eliminate, it ends up getting into the rivers, which ends up getting into the streams, which ends up getting into the oceans and ends up evaporating back into the atmosphere. And, of course, that falls down as rain, and then the cycle continues, and the water, it's always been here for bazillions of years or billions of years. Well, I would say as a chemist, that is going to depend on how you look at it. So people will say, for example, that, we drink water that dinosaurs have peed out because of this. You probably have all heard of this. Well, as a chemist, I don't buy that argument. And let me tell you why. Okay, so it works like this. We all know that water is made of H2O, right? H2O. So it's an oxygen in the middle, and there's two hydrogen atoms attached to those oxygen atoms. And it looks like this. Hold on, I got to draw on something here so you can see it. Okay, I'm going to just draw the water molecule just so we can all see it. H-O-H. Here we go. Like this. So there's your water molecule, yeah? And there's, of course, bazillions of these water molecules in this glass right here. And in your body. They're all over the place. So I'm going to draw another one right next to it like this. Like this. Okay. So there's two water molecules, yeah? And there's a whole network of these in, any sample of water in your body. And I'm just going to draw one more just to try to make the point here. Bear with me. I think this is an interesting fact. And if you're a nerd, you'll agree. I'm a nerd. I'm definitely a nerd. So, okay, here we go. We got this network of water molecules. Well, what happens in water is these hydrogen atoms, they exchange. I mean, we call it hydrogen atom exchange. It happens in all sorts of stuff when there's an OH bond like this on molecules. So what I mean by exchange is this hydrogen atom will pop on to this water molecule down here like this. It'll go like this. I'm going to draw a new bond. So I drew this hydrogen atom is now attached to this oxygen atom. And see, this hydrogen atom here, well, this has got to go back to H2O. So this one's going to pop off. And this is going to go to a different water molecule. Well, that happens, and then this bond would break. Well, look at this. This water molecule here is different than how it started. It has a different hydrogen atom. And that means that this water molecule on hydrogen atom exchange, which actually happens billions of times a second in all the water in any sample of water, it happens billions of times a second. So that means that any individual water molecule in a sample of water only lasts for roughly a nanosecond. So even the water in your own body, the water molecules in your own body, aren't the same water molecules from 1 second to the next. So that's why I don't, as a chemist, I don't buy this idea that, we drink exactly the same water molecules that dinosaurs have peed out. I apologize. I know that was really long and really long-winded, but I was asked for an obscure chemical fact, and I gave you one. I'm not drinking this. But the thing that matters is that it's water, right? Well, Jazz, I think you're right. I think it's a philosophical question. Some people would say, even given the knowledge that I just argued, some people would say, well, it doesn't really matter because it's the same hydrogen atoms and it's the same oxygen atoms. But even consider this. The water molecules that are in the atmosphere, those get transformed into molecules of oxygen in the process of photosynthesis. So the O's in water, the oxygen atoms in water, when they go into plants, they get transformed from water into O2, the oxygen we breathe in. So while it is true that the oxygen atoms that are in, water today, well, I guess it's not. That doesn't mean that they are going to be the oxygen atoms that will be in water tomorrow. So what does a body of water at rest look like? Joe, I'm not sure I understand the question because I'm not sure if you want me to answer the question in terms of a large body of water, like a lake at rest, or if you're asking me to talk about a large number of water molecules that aren't doing any exchange. What's this question? Do you use a vacuum changer to extract salts from some of your experiments? Curious as to what you'd recommend to make some of these back into salts. Let's say the calcium acetate from shells and vinegar. So if I was going to try to get calcium acetate from shells and vinegar, what I would do is I apologize if you already know this, I would take some eggshells and I'd dissolve them in vinegar to make the calcium acetate, and then I would just boil it. I would just boil the vinegar off. And then you're going to end up with, the residue, which is going to be your calcium acetate. So long, unknown. Thanks for hanging around. Jim Bros wants the rainbow ×2. Joe Moore, you're asking like a lake. How does water become solid when freezing? The structure of the bronze. Chad, I did a video on this. So what happens is the water molecules organize themselves into hexagons. And when those hexagons are able to form throughout the entire structure of ice, it's actually a 3-dimensional hexagon. It's not a 2-dimensional one. So you need to look at the hexagons in 3 dimensions throughout the entire structure of ice. When that happens, the water, it becomes solid and it goes ice. Why, if you have 2 glasses close together, wine almost full with water and the other almost empty, does the other glass start to fill up with water and the other glass drain of water? So Sputnik. Together wine almost full and the other almost empty. That's a good question. I'd have to think about that. I'm sure it has to do with evaporation and condensation. How's this contraption churn up the liquid? It's just got a little stir bar down here at the bottom that I inside this box there's some magnetic fans, and as those fan blades spin, the you know, the little stir bar spins, and that's what churns the liquid. Oh, Yaj, I'm not going to be coming Walter White. I'm not Breaking Bad. I will not break bad. Hopefully, hopefully I don't do that in my life. But okay, here let's do another experiment. Let's do this experiment here. I want to do this one here. Hopefully it'll work. I'm not sure it's gonna, but I got a little bit of water, or I don't want to say water. I have some fluid here. It's not water. It's a little bit of isopropyl alcohol. And to this isopropyl alcohol, I am going to add, oh, yep, here it is. I'm going to add some water. So let me get the water in here. Actually, yeah, I better add the water. So here we go. Let's get the water in. Give me a second. We got to add the water. All right. All right. New experiment. All right, here we go. All right, I'm going to add it in. Let me know when I'm getting near the top. Close enough. Okay, great. I got some alcohol and water mixture, and you can see that alcohol and that water, it mixes. How do I know it mixes? Well, we're gonna add a drop of food coloring just to make sure. Okay, so I'm gonna mix it like this. See if it mixes in all proportions. We're gonna add 2 drops of green food dye, maybe 3. Let's see. Here we go. 1, 2, 3. That's kind of beautiful in its own right, isn't it? Just watching the dye mix through. Kind of pretty. Let's mix that up, okay? We're going to mix this up. All right. Sorry, I got to try to keep it in the field of view. Here we go. Let's mix that up. It's green all the way through. Nice. Very nice. Now what I'm going to do is I'm to this mixture. Now notice we have green food dye. We have isopropyl alcohol. We got water. It looks like it's mixed all the way through. It's well mixed, yeah? So now what I'm going to do is I'm going to add, by the way, the water's been warmed a little bit. To this mixture, I'm going to add some super washing soda. You buy this in the laundry section of any store. So in it goes. Let's put the super washing soda in. Get an idea how much I've added. It's quite a bit. And it goes. All right, now I'm going to give that a good old shake. See if I can get that stuff to dissolve. You can tell that not all the solid has dissolved yet. And you can tell that because it's cloudy, like I can't see through anymore. So let me go ahead and give this a nice shake. All right, here we go. Let's shake this up. And we're going to shake this until all of it dissolves. Doesn't look like yet, does it? Looks like the comments have stopped. I apologize. I'm having a hard time. There we go. I apologize. Yeah, sodium carbonate's a salt. Sodium carbonate's a salt. No, this is Jim Bros. This is green food dye. It is. I apologize. I missed the comments there for a bit, but I hit a wrong button on my phone, which is how I film these experiments, and I was missing the comments, so I apologize. So what's this at? What do you think about Breaking Bad? Do you think it's a show that attracts people to learn more? I think so. I think maybe. Okay, what can you do this with ethyl alcohol? I think you could. I think you could do it with with ethanol. Okay, here we go. I've not done it with ethanol, but I imagine it will work. Let's just let that sit right there and let's see what happens. Oh, baby, it's working. It's totally working. Look at that. Can you see it? So what we're doing here, Blaster, is I have added a mixture of a mixture of water and isopropyl alcohol. I added green food dye, and then I added some sodium carbonate. And look at what's going on, man. Look at this. We got yellow on the bottom, we got blue on the top, and we got green in the middle. Isn't that beautiful? Very cool. And if you want to know how this works, you can check out my channel. I've got videos on this that explain everything that's going on. And you can see that green is starting to disappear. It looks like we've got we've got blue on the top and we got yellow on the bottom. So what's going on here? What's happening here is when I add the salt is very attracted to the water. So there's like forces between the ions in the salt and the water. And the water and the salt are so attracted that the alcohol cannot compete. So, to get the water and the alcohol to mix, those molecules have to be attracted to one another. Okay? But when you add the ions of salt to this, those dissolve in the water and they so strongly attract to the water that the alcohol gets pushed out. It can no longer compete and attract the water enough to stay mixed with it. And that's why you get the separation. Now, why did the green separate into yellow and blue? For the same reasons. You see, green is made of yellow dye and blue dye, and it turns out that the yellow dye, for reasons I'm not going to get into, but you can check out my videos, the yellow dye is able to strongly attract to the water and the ions, but the blue dye is not, and that's why that separation occurs. Can I make a third layer with oil? Asked Chad. The Guardian, the third layer you can make, but it's difficult. I can't remember off the top of my head how to do it. The salt I used was sodium carbonate. This is like polar, non-polar stuff. You guys want to see this again? I'll tell you what, if you want to see this again, drop me a yellow heart and a blue heart in the chat. I've got enough material to do one more, or I can go back to doing the rainbows. Yeah, this is like intermolecular. Hydrogen bonding is involved. L3s are. Again, if you look at, I have a long form video on this you can check out. It talks all about it. Hello there, Xavier. Yep, a lot of people say it's like the Ukrainian flag. I might do a video on that. So Adi Dog wants to see it again. And yes, Albert, it does work with sodium chloride. However, you have to use different dyes if you're going to try it with sodium chloride. It will separate, but the special separation of green dye into yellow dye and blue dye, that only occurs in my observations when I use sodium carbonate. Let me show you where I get the sodium carbonate. Where is it? Where's my box of sodium carbonate? I don't know where I stuck it. It's called super washing soda. It's a yellow box, and it comes at the, oh, here it is. Here it is. You can get it in the laundry section. Here it is right here. Super washing soda. I'm not trying to sell it. I'm just showing you how to do the doggone experiment. Let's do it one more time, and I'll talk about it as we go through. Let's do it one more. Okay? Here we go. By the way, if you do want to do this, you have to warm. So this is warm. The water is like I got it really hot out of my tap. If you're using sodium carbonate, you got to use warm water or it doesn't work. If you use regular water, what you get is like a green and a yellow is what you get. Okay, let's try this one more time. I've got here it is. Got my alcohol. Yeah, we're going to add some water to this. By the way, the alcohol that I use is 70% isopropyl alcohol. And I add equal mixtures of 70% isopropyl alcohol and water. So here goes the water. That's 70% isopropyl in there. I try to add roughly, an equal amount of water, but it's too much. Crap. Oh, crap. Jeez. Oh, crap. I made a mess. Oh, shoot. Give me a second. Oh, that happens. Oh, nuts. I got a mess to clean up after the live is over. Well, I don't know if this is going to work as well because my ratio is not going to be quite as good, but we'll give it a shot and we'll see what happens. Oh, nuts. Okay, so in goes a couple drops of green food dye, McCormick green food dye, 3 drops. Oh, shoot. Now I'm going to cap it off and give it a stir. I don't know if it's going to work, folks, because I messed the ratio up when I added too much water, like an idiot. Okay, here we go. Let's mix this up. Now Red's been doing some crazy stuff lately. He made atomic metal. Yeah. I don't do stuff that's unsafe. Let's just put it that way. Can you separate water from gasoline like this? Water and gasoline won't mix to begin with, so you don't have to worry about that. Alcohol and water tend to mix pretty well. What would happen if I put peroxide in the solution? Probably nothing. Probably nothing. Okay, here we go. Can I add heavy water? Chad, what an interesting idea. That is not something I've done, but it is something I would love to try. The issue is how expensive the heavy water is, but that does sound easy. Hello there, Sarah. You got it, Guardian. Here we go. Okay, in goes the sodium carbonate. In it goes. I thought I saw a question about disposal. I just saved these. I mean, you know, kids love these bottles. You just tape up the, tape up the top so that they won't open it, like duct tape. You duct tape it so they can't open it, and then give them to the kids, and they enjoy just shaking them up and messing around with them. Okay, here we go. That's the sodium carbonate in some very warm water, to which there's also alcohol added. Jesse, I am trying an experiment that I may have messed up because I messed up the ratio, but what should be in here to make it work is water and isopropyl alcohol. And to that mixture, I added some green food dye, and I have also added some sodium carbonate. Would this work with separating gasoline and water? Gasoline and water won't mix to begin with, so it doesn't really matter. Let's see if this works. Hey, it's going to work. You can already see, yeah? You can see. So what's happening here is the alcohol is being forced out of the water layer because the salt and the water are so strongly attracted, they push the other out. It's kind of like, you know, when two people get together that really love each other, they date each other exclusively. So you can think of it as the salt and the water are dating each other exclusively, and they're pushing the alcohol out. The alcohol cannot compete with the attraction of the salt and the water, and you get a really nice separation there. Now, you might say, well, why did the green color go to blue up here and yellow down here? It's the same kind of attraction thing. The yellow dye is strong enough to be attracted to the water and the salt, but the blue dye in the green dye is not, so that goes into the alcohol. Thank you there, Jesse. Appreciate that. Guardian, I hope I answered the question of why the colors separate. L3 Czar, I want you to go to my, if you go to my YouTube channel and you look at my YouTube shorts, also my long form, I have videos on these, and you can get more information on exactly how to do these experiments. Can I mix water and bromide? Sure, you can do that. Sodium bromide is real easy to add to water. I agree there, T-Mac. It does look a little like a Ukrainian flag, doesn't it? Jet, I apologize. I can't do it again. I don't have enough materials to do it a third time. I don't have any fluorantimonic acid, but I do have some sulfuric. I'll tell you what here. We're near the end of the live, and so what I'm going to do is I'm going to, what I do at the end of the live, I'm just going to warn you. I flipped the camera around. You see my ugly mug. And if you don't want to see an old man who's almost 57 years old in his basement, then now's a good time to leave the chat. I'm just going to warn you ahead of time, okay? So that's what we do for the end of the live. I just, turn around, let you see my face, and we talk to each other for a bit, okay? Thanks there, Mr. Tornado. And if it's okay, I also want to let you know that I've been sponsored by the Curiosity Box, and I'm not gonna do it for long. I'm just gonna show you like a cool T-shirt that they sent me, and I have some videos coming out on some of the other things that they have in the Curiosity Box, which I actually found pretty cool. So, I am a teacher, L3Czar. Yeah, I did some experiments with bromine. Okay, let's flip this baby around. There we go. Hello, everybody. These are my readers, so they're both readers and my safety glasses. Infinite, I don't have any fluorantimonic acid. Thanks, Yaj. Vsauce, yeah, Vsauce sent us that. Yeah, hello, Chad. I wish you were my student there, Gavin. Thanks there, Funk X. Excels, I don't believe so. Thank you. Thank you for the subscription. I appreciate that. Thank you there, Banksy. I love it. 1990s. Come on, man. I'm all about the 1990s. Hey there, Scott. You want a drop of sodium hydroxide? How much alcohol is still at the bottom or water at the top? Oh, it's about half and half. Vsauce or Mark Rober? I don't know. I like them both. Thanks there, Gavin. Sulfuric acid and salmon. What an interesting idea. Thanks there, Demos. Uh-oh, Grandpa's Breaking Bad. I don't like to hear that. Any thermodynamic missile? I don't understand. Love you too there, Ash. Thanks. Thank you there, Joshua. I teach college. I'm in my house, Yash. Here, let me show you this cool shirt. Let me just, I mean, it is pretty cool. You know, if you're into this kind of thing, I guess I can get my gloves off. So I'm done mixing the chemicals. This is a pretty cool shirt. At some point, I'll put their link in my video so you can, you can buy from them and give me a little, I guess they give some folks too. But here, yeah, we got like a boar model on a t-shirt, like the old boar model. You can see the different N equal whatever energy levels. I think this is for xenon. So this is like a boar model description of xenon on the t-shirt, which if you ask me, that's kind of cool. I think it's pretty cool. I got that in my curiosity box. What I really was interested in, and this is what I'm gonna do the videos on, I did some experiments with the, they make it where you can make chocolates that have little rainbows, a diffraction grating on the surface, and you can see like little rainbows in the chocolates. It was really cool. Oh yeah, absolutely. Thanks here, Sputnik. I'll take it. Why do they make you learn all the different types of atomic models? L3ZAR, I think it's all about, part of, in my opinion, part of learning about science is learning what people thought and then how that changed over time as new data became available and people were able to explain that new data in better ways, and sort of being able to have that long view of, hey, this is what we used to think, and you know what, we did it a little bit better. It gives you a great perspective on how human beings figure things out. It gives you a great perspective on the scientific method, and it allows you to say, okay, if this is something that I want to go into, I have that long view of what humans know and what they knew and what they thought about and what we know today, and how can I push that? How can I take what we know today and what we think today and make it stinking better? And that's what I love about science. I think that's one of the most beautiful things about science. When we do science right, we recognize that we're wrong. We are always wrong, and we're always trying to get better. And more than I think any other discipline, science and mathematics, we say to ourselves, yes, we have this knowledge, and yes, it's good, and yes, we can apply it in a bunch of different ways, but that doesn't mean it's going to work forever. We are going to try to push this, and we're going to try to be better, we're going to try to explain things better, and we're going to try to figure more crap out, baby. And that's what's so beautiful about science and mathematics. Thank you there, T-Mac. Well, Demo says scientific advancement is one of the few things that have no downsides. Well, I'm not sure I agree, right? I mean, advances in technology are always a mixed bag. Always a mixed bag, right? When we learned about the atomic nucleus, it's wonderful knowledge to be able to understand and probe the nucleus. But you can tell where I'm going with this, right? When we understand the atomic nucleus, we can use nuclear power to heat our homes and do all the stuff that we need without, putting fossil fuels, carbon into the atmosphere. But of course, the downside of understanding the nucleus. Now governments can, use nuclear weapons as a source of power, and that causes issues. Ecstasy has a question. Oppenheimer, you got it, L3ZAR. Hans, I'm not always right. I am not always right. That is antithetical to science, man, right? You know that. Disagree with me if you want. That's the heart of science, right? What's my view of artificial intelligence? Asks Ashwath. I cannot, Hans. I cannot. So, yeah, I do some stuff on Instajage. So my view on artificial intelligence is the way I view all technology. I'm sure there's some holes in this thinking, but I look at it like this. Human beings are always going to figure crap out. And when we figure crap out, we are going to be able to do more stuff than we did before. And one of these things that's now on our plates is artificial intelligence. That means there's going to be people who are going to use artificial intelligence. It's going to happen. It's not like we're going to put that cat back in the bag. So let's think about this. If we're going to have human beings doing artificial intelligence, do we want people who use artificial intelligence for good or not? Of course we do. That's what we want technology to do. We want technology to better human beings' lives. And so it's just a tool like any other tool. It's a powerful tool, nevertheless, got to be respected. People are going to use artificial intelligence for evil. It's going to happen, which means we got to have people using artificial intelligence for good, which means we got to educate people on how to use artificial intelligence appropriately. That's my opinion. You don't need to agree with me, but that's just what I think about new technologies. Hello there, Holden Cox. Welcome aboard. Sputnik. I hear this a lot. Everything is mathematical, but I think it's deeper than that. I think the philosophers might disagree with you, right? The philosophers would say, well, even mathematics is based on philosophy. I don't know. AI is watching. Oh, nice, Tim. Robots can deliver bombs. Yeah. I do not, X. I do not. So Akuma says AGI is what really scares me because it becomes more than just a tool. So Akuma, did you mean AI or did you mean AGI? And if you meant AGI, please educate me on what that means. I do not know what AGI means. Carbonyl groups. Carbonyl groups are just a C double bond O group. You can find them on ketones in which the C double bond O group is in the middle of a molecule. You can find a C double bond O group on the end of an organic molecule, in which case it's an aldehyde. And you can find a C double bond OH group on the end of a molecule, which makes it an organic acid. How you doing there, Akshat? My Insta is Tommy Technetium, Yash. Frank's saying he's an AI bot. Funk asks, do I believe in God? So here's the deal. Funk, I need you to define God for me. I need you to define God for me before I can answer that question. I mean, I think that's difficult. Yeah, I know, Hans. What do you think about the quantum computers that are being developed? I think it's cool. I think it's cool. No, Sebastian, I am not. Do I go over halogens on my YouTube long form? No, I have a short form on the halogens. OK Storm, I don't know enough about it to comment. What's my favorite metal? I'll tell you what my favorite metal is. This is going to sound weird at first, but my favorite metal is hydrogen. And you might say, wait a minute, hydrogen's not a metal? Well, not here on Earth, it's not. But what's intensely interesting to me about hydrogen is that if you increase the pressure on hydrogen atoms enough, which happens in the cores of two of our planets in the solar system, Jupiter and Saturn, in the cores of Jupiter and Saturn, the pressure's high enough where the hydrogen atoms become metallic. That's right. In the core of Jupiter and in the core of Saturn, you have metallic hydrogen atoms. And because of this interesting fact, and because hydrogen happens to be my favorite element, hydrogen's also my favorite metal. Okay. All right. I'm missing a bunch of comments here, so I'm trying to catch back up. Mix sodium and water and put it in my hand. Not gonna happen. I try not to do stuff that's dangerous. Here's my dog Ruby. You want to say hi, Ruby? How you doing there, big girl? She's been a good friend of mine for about 11 years. She's a great pal. All right, folks. I think my wife is home. I want to go say hi to her and spend some time. Uh, want to spend some time with her. So thanks for hanging out. And I do too. I love my dog. I love dogs. And I love you all. I do. I love you all for being here, hanging out with me, helping me get through the afternoon. Thanks for helping me live my dream of doing science experiments with people, which I love to do. And hey, always be checking out the beauty that surrounds you. It's always there. Just take some time to pay attention and think about the science, and you all have a great day. I may check you all out tomorrow. Lazar, Oshkot, Jesse, Dimos, Sebastian, Frank, Hans, Yaz, and I know I missed a couple.